everybody, in case you needed the help, this is a quick review of classwork 2 and 3. I'm very quickly going to go over 2 because we can, mostly, I think most of you got through a good portion of number 2, and then I'll go over 3 in more detail because it is a little bit more challenging. So for number 2, it says find a combination of necklaces and bracelets she could sell and make to make exactly $100 profit and then more than $100 profit. So exactly $100 profit. If she's selling each necklace for $9 and $5 for each bracelet, she could sell then maybe 0 necklaces. That would be the easiest. And then if she's making a $5 profit, she could make 20 bracelets. That would be totally fine. And 0 necklaces and 20 bracelets also gives us our y-intercept, which is nice. If she wants to make more than $100 profit, I mean, really, she could make 10 necklaces and 10 bracelets, and she would make $90 plus 50, 140. So 10 of each would also get us more than $100 profit. To make this equation, we have 9 per necklace, and if we look at our graph, the necklaces are on the x and the bracelets are on the y-axis. So we're looking at 9x plus 5y, and if she's making exactly, it would be equals $100. If we wanted to show an equality where she makes more than, we would do 9x plus 5y is greater than $100. And then to graph this, well, we have the y-intercept already as 20. But we can also put this in slope-intercept form to help us figure that out. So we have 5y is greater than negative 9x plus 100. Divide both sides by 5. We get y is greater than negative 9/5 x plus 20. So the slope is 9 over 5. Now this graph, you notice, is going up by 2's, right? We have, so 18 is here, 14, 10, 6, 2. And so if we're going down 9, we would go down to 11, which is going to be between 10 and 12, and then over 5, which will be approximately here, okay? Again, this is 6, so 5 would be between 4 and 6. And then going down another 9 and another 5 is going to get us down to 2 and then over to 10. So this would be another point, and then you have a line. Now this is going to be a dotted line because it is greater than, not greater than or equal to, and then we need to test a point to see what would work here, okay? So when we're testing a point, we want to see when she's going to make greater than $100 profit. If we test 0, 0, right, we'll get 0 is greater than 0 plus 20. That is not true, right? So that side does not work. The side that does work is this side right here. If we were to test, for example, 10, 10, 10, let's try that. That's a nice easy one. We would get 90 plus 50 is greater than 100. And that is true. 140 is greater than 100, right? So we know that that side works. And then this last one says, is this a solution? So technically it would be in, right, like 3 comma 3 would be here, and then 18 would be up here. So technically it'd be in the zone that we've shaded in. However, can we have 18.6 bracelets? No, we wouldn't be able to sell 18.6 bracelets. We can only have whole bracelets. So no, because we are limited to positive integers or whole numbers. All right, let's look at number 3. So number 3 is a little bit different because this band is trying to raise $20,000 at least. So now we already know we have a greater than or equal to 20,000 situation. And they sell $25 for tickets are $25. So 25 times T or X, right, since we have number of tickets sold on the X-axis. But they have to pay $12.50. So if you have to pay $12.50, then we have to subtract that times the number of concerts that they hold, because they have to pay every time they hold a concert. So 25X minus 1250C has to be greater than or equal to 20,000. So then it says graph the solutions. So again, let's go ahead and put this into slope-intercept form. That C is actually a y, if it's helpful for you to consider it in terms of x and y. So we'd have negative 1250y is greater than or equal to 20,000 minus 25x, or minus 25x divided by minus 25x plus 20,000, we're going to divide by 1250 on both sides. Now notice I am dividing by a negative, so I'm going to flip my sign now, and we'll have y is less than or equal to whatever we come up with. And let's put our x value first. So a negative divided by a negative is going to be positive 25 over 1250x, and then 20,000, oops, let me get out of this, clear, 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 20,000 divided by 1250 is 16, and this is going to be minus 16 because we have, oops, excuse me, well, all right, minus 16, write it down here, because we have a negative divided by a positive. So negative 16 is not on here, and so we can't start our graph there. All right, so instead we need to figure out where we're going to start our graph. And so this is where your x-intercept is going to be helpful. So when y is 0, what does x equal? Well, when y is 0, if we didn't have to pay that fee, we would have 25x equals 20,000, right? That's if we don't have to pay the fee. So 20,000, I think I put too many, oops, 2, 3, okay, divided by 25 gives me 800. So 800 is when y is 0, then x is 800. So that is our starting value here on the x-axis. So 16, negative 16 would be somewhere down here, right? But we are starting here instead because our x-axis, our y-axis doesn't have a negative value shown. So then we're going up 25 over 1250. That's not like the best slope to look at because it doesn't go up past 24. So let's look at what that is. So 1250 divided by 25 is 50. So 25 over 1250 is the same as 1 over 50. So our slope is 1 over 50. And that's our slope, positive 1 over 50, right? Because we did a negative divided by a negative. Going up 1 and over 50 is also a little bit tricky because we're going by 2's here. So actually, I would multiply to get a better slope to work with. I'd multiply this whole thing by 2 over 2, and we'll get 2 over 100. So I go up 2 over 100, up 2 over 100, up 2 over 100. And you're actually going to get a very easy line to graph once you figure that out. All right, so again, my slope is 1 over 50. It's a little squished here. I'm sorry, I don't have a little more room. But our slope is 1 over 50 because it's 25 over 1250, which is the same as 1 over 50. I'm multiplying it by 2 so that I have 2's and hundreds to go by, 2 over 100, up 2 over 100. And now this is going to be a solid line because it is a greater than or equal to situation. All right, now we're talking about a greater than or equal to situation. So if I were to plug 0 in here, 0 minus 0 is not greater than 20,000. So we know that this side doesn't work. If we were to test a point over on the right side here, though, that would work. So let's take a look at, for example, 1,002. Right? So if they have 1,000 people coming to their concert, that's going to be $2,000, right? I'm sorry, 25,000. If they have 1,000 people, it's $25 a ticket times 25. We have $25,000, right? Minus, they have to pay $12.50 for each one. So if they have 2 of those, they're going to pay $12.50 times 2, and so 2,500 minus 25,000 minus 2,500 is going to give us 22,500, which is more than 20,000. So that tells us this point right here, check, does work. And so that proves that this side is the side that we would shade. It says name 2 possible combinations of number of tickets sold. So all you have to do is look in this shaded in area, what part of that shaded in area works, and list out those combinations of number of tickets sold and number of concerts. This next part asks which combination of tickets and concerts would mean more money for charity. So you have to choose A or B in each of these scenarios. The best way to do that is to plug that into the equation and see which one's going to make more money, or look on the graph. So on the graph, 1,300 tickets and 10 concerts would be, let's see here, 11, 12, 13 here, and then 10 would be right on the line. all right? So that would meet the constraint of 20,000. That would be $20,000. 13,005 concerts means that they are actually going to be paying less money, but still with the same number of tickets sold, right? So that would be like here-ish. And so that actually is going to be more because they have to spend less on the concert. So B would be.
Please write an option. Please write.
Sorry about that. For this second question, if we look at this, we're looking at 1,600 tickets and 16 concerts. So that's again on the line, right? 1,600 and 16. So that meets the constraint. And then we have 12,000 tickets and 9 concerts. So 12,000 and 9 concerts would be here just slightly above the line. Now notice that one is outside of the shaded area. It's not in the shaded area, which means that would not mean the constraint and we would not make enough money. And so that means that this one has to be more because we know this one is 20,000. And if this is in the unshaded area, then it's not a solution. It's not greater than 20,000. Letter 8, I would strongly recommend for this one, you can plot it on your chart and kind of based on the graph, think which one would make more money, but I would also strongly encourage you to plug in the numbers, right? So plug in 2,000 times that $25 plus 4 times $12.50 and see what does that equal, okay? Not a greater than or equal sign. It is greater than or equal to 20,000, but see how much that would be. And then same thing here, 2,500 tickets times 25 plus 10 times 12.50 and see how much that costs. And also, I made a mistake. This should be minus because we're subtracting the fee, right? So not adding the fee, subtracting the fee there. So go ahead and plug those numbers in, see what you get, and see which one you think is more.